Hey guys, welcome to another lecture from ecopoint. Today, again, I have a practice set for you from the point of view of CUET PG entrance. Just have a quick peek into the questions and then let's start solving them together. So, in minimum stipulated time, these are 5 questions. Let's solve them. The first question from sequences. If xn is convergent, sequence in R and Yn is a bounded sequence in R, then what can we conclude? Do you think xn plus Yn is convergent, xn plus Yn is bounded, xn plus Yn has no convergent subsequence, or xn plus Yn has no bounded subsequence? Well, we're talking about xn plus Yn. So first thing, xn is convergent. That automatically implies that it has to be bounded. Every convergent sequence is bounded. Yn is bounded. So that means xn plus Yn, when you take two bounded sequences, of course, the sum is bounded, right? Bounded is like you having two walls. It's bounded above as well as bounded below. So the sum will also be bounded above as well as bounded below. And if that's the case, option B is the correct answer. In fact, we cannot say whether xn plus Yn is convergent because we don't know about Yn. You can have bounded sequences which are not convergent. And it has no convergent subsequences. That would be wrong to say because it should have some sequence which is subsequence which is convergent. It has no bounded subsequences. Again, that would be wrong to say. Next question. fxy is a two-variable function log cos square ex square plus sine x plus y. Then del upon del y into del upon del x of fxy, that is the cross partial, is, these are the options in front of us. What would it actually be? Now, this is del square, del x, del y. Okay, so you have to differentiate with respect to x and y. So partially differentiating this with respect to x, what's going to happen? It's log of cos square. So when you differentiate with respect, when you differentiate log function, so it becomes 1 upon whatever log of you have. So 1 upon cos square ex square. But then chain rule will play its role. So therefore, you will have to differentiate cos square. So cos square will be 2 cos theta. Theta is ex square into the derivative of cos, which is minus sine. So minus, that is why you have a minus here, minus sine ex square. But then you have ex square. So chain rule, you have to differentiate that also. Derivative of e is just e, so ex square, but x square will be differentiated. 2x you will have. So this is what you will get. Now cos ex square will get cancelled. One of the powers in the denominator will get cancelled. No, you also have sine x plus y. Okay, so sine x plus y also will get differentiated and you'll have cos x plus y there. Then if you look into the scenario, you have 2 and 2 getting multiplied. So minus 4 sine ex square into x ex square upon cos ex square plus cos x plus y. Now you have to differentiate with respect to y because this is del upon del x. So del upon del y. Actually, when you look into the question, you should realize that this is only based on x. So when you will be differentiating with respect to y, this will turn into 0. So only what matters is sine x plus y because that consists of both. And but of course, when you are double differentiating, so you have already got cos x plus y and you differentiate that with respect to y, you will get minus sine x plus y. So the answer would be C option, minus sine x plus y. Quickly, let's move on to the next question. X to the power 5 minus 5x plus 2. Then f has no real roots, f has exactly 1 real root, f has exactly 3 real roots. All roots of f are real. Well, let's see what will be the correct thing. Now, Whenever you have a polynomial like this is of course continuous and differentiable. So with the help of continuity and differentiability, you decide for upon the roots. You don't really try to find out the roots, okay? So what we can do is we can differentiate it, or we can think of some other scenario. Well, if you differentiate it, what you get 5x to the power 4 minus 5. Is it helping me? Let's see. Uh, Before that, in fact, what also I can do is I can just look at the values of this function at certain particular points. The easiest points to look at 0, 1, minus 1. So, well, f0 is 2 and f1 is minus 2. So, by IVT, by the intermediate value theorem, basically what's happening is your function had a positive value and it is turning into negative. That means it will have to cut the x-axis somewhere in between 0, 1. So there definitely is some c such that fc is equal to 0. So therefore, I know that we do have a root between 0 and 1. In fact, if you see f of minus 1, you will get minus 1 plus 5 plus 2. So you will get 7 minus 1, that is 6. But if you look at f of minus 2, what's going to happen is that you will get minus 32 plus 10 plus 2. So which means you're getting minus 20. So again, what you would see that this is greater than 0 and this is less than 0. So there is again a change. That means it will cut the x-axis at least at one point here as well. There does exist a c belonging to minus 1 and minus 2 such that fc is equal to 0, at least 1. But this is not giving us the exact number. Now, what we also can apply here, it is giving you an idea. But what you can also apply here is something called the Descartes rule of sign. So I just want you guys to note it down. The number of positive real roots of fx is equal to number of sign changes of fx. That is, in our case, if it is x to the power 5 minus 5x plus 2. So how many times is the sign changing? It is changing 2 times. Positive to negative, negative to positive. Okay. So number of sign changes of fx or is less than the number of sign changes of fx by even number. That is, if it is, the number of times it is changing sign is, say, is equal to 5, then the number of positive roots will be 4, 2, even numbers. Okay. The number of negative real roots, just like this, is equal to the number of sign changes of f of minus x or less than number of sign changes of f of minus x by, again, even number. Now, in our case, what's happening for positive roots, if we look at, you are getting two changes, sign changes. So we can say that you have two positive real roots. And if you look at f of minus x, it turns into minus x to the power 5 plus 5x plus 2. So there is just one change, right? If there is just one change, then what happens? It is one negative real root. Either it is just one negative real root or it is less than. We already know that real roots are there. That is something that we know by IVT. In fact, so from here, what you get, two positive real roots here and one negative real root. So you get three roots, and that's option C. But without this also, you can, figure out what the scenario would be. By taking the derivative, you will figure out that 5x to the power 4 minus 5 equals to 0. That means your stationary points turn out to be plus minus 1. Then you can figure out that your function is increasing, then decreasing, and then again increasing. So what's happening? It's increasing from minus infinity to minus 1, it's increasing. Then it is from between minus 1 to 1, it's decreasing. And then from 1 to infinity, it is again increasing. And we already have an idea of the values that we are attaining. So with that, we get to know that, it must be cutting the x-axis here, here, here. One time between, you have a root here. here and here. So that is why you have exactly 3 roots. Okay. So if you don't remember the Descartes' rule, then also you can, by using calculus, figure out your answer. Next question. A standard fair die is rolled until some face other than 5 or 6 turn up. That is 1, 2, 3, 4. Let X denote the face value of the last roll. So you are rolling whatever comes in the last roll. And A is the set, X is even, and B is the set, even. X is at most 2. At most 2, that is 1, 2 can happen. Then you have to tell what is the probability of A intersection B. Well, if you look into this problem in a very simple manner, I would suggest you to do that. So the crux of the story here is that X can take 4 values. It can take value 1, 2, 3, 4 because we don't want 5 or 6. Okay. So therefore, the options that we have is 1, 2, 3, 4. So X can take 1, 2, 3, 4. And if you think logically, X can take any of these values with the same probability 1 by 4 actually. Even if you will create like the sequence of values, you will get that 1 by 4 will turn out to be the probability. Wherein A is X is even, 2, 4 is the only possibility for even. B is X is at most 2, that is 1, 2. So two outcomes here, two outcomes here. We want to talk about the intersection. Yes, there is an intersection. So what will be the probability of the intersection? Total probability is 4. Total 4 outcomes are there. What are the common outcomes that we are getting? 2. So therefore, 2 as in the number 2, the value 2, or there's just one outcome basically. So 1 upon 4 should be the correct answer. That is option C. I would suggest you guys to think of this problem in a very simplified manner. Next is a question which you should try out definitely without looking into this video, but definitely you should come back to the video to see whether you've done it right or not. Suppose mod 3x plus mod 2y is less than or equal to 1, then the maximum value of 9x plus y, 4y is. So it's like an optimization problem. So you have to find out 9x, maximum of 9x plus 4y given mod 3x plus mod 2y is less than or equal to 1. Right? So these are the values with us. I would take you through this question in a very, very simplified manner by looking at the XY plane. So let's look at the XY plane. Your XY plane will give you your answer if you draw the condition properly. Well, let's start with our inequality. Mod 3x plus mod 2y less than or equal to 1. On the xy plane, what will it look like? Get the point of intersection with the x-axis and y-axis. So put x equal to 0 and then y equal to 0. When x is equal to 0, you get mod of 2y is less than or equal to 1. That means 2y is in between minus 1 and 1. That means y is in between minus half and half. So that is why you will see the point of intersection with the axis, y-axis. You will see here minus half, half. Similarly, when y is equal to 0, mod 3 is less than or equal to 1. So x is between minus 1 by 3 and 1 by 3. And hence you have the points here. Now, you can also think what this graph of this inequality will look like. So for that, think in terms of all the quadrants. So the first quadrant, x and y both are positive. If x and y both are positive, then that means from the modulus, you get positive outside. Mod x, you know that mod x is equal to x when x is greater than or equal to 0 and minus x when x is less than 0. So accordingly, we solve the inequality here. And that means we get 3x plus 2y. So this is the graph of 3x plus 2y equal to 1. And in the second quadrant, x is negative, y is positive. So we get minus 3x plus 2y. So minus 3x plus 2y equals to 1. Now in the third quadrant, Y is negative, X is also negative. So you get minus 3X minus 2Y equals to 1. And in the fourth quadrant, Y is negative, X is positive. So 3X minus 2Y equals to 1. And since the inequality is less than or equal to 1, so everything inside this, that is what I've marked as yellow. That's the area that we are talking about, right? Now we want the maximum of your objective function, which is 9x plus 4y. 9x plus 4y. So that's your z, and this is the feasible region. Where will you find your optimum? Endpoints, the corner points. The corner points are minus 1 by 3, 0, 0, 1 by 2, 0, minus 1 by 2, 1 by 3, 0. The value, as you can see here, minus 3, 2, minus 2, 3, 3 is the biggest value. So what is the biggest value? The biggest value is 3, which is option C. I hope these questions will really help you out in solving the actual exam. Thank you very much. Keep practicing.